Okay, we're group 14 and we're going to be doing problem 2.77. The problem asks for us to solve for unknown h to where the maximum height that the water level can be without toppling over the wall. And it's a 4-foot high wall, 8 inches thick. Here we have our free body diagram, which shows the weight of the wall, the resultant force from the water, the h height that we need to solve for, as well as the length from the bottom and the length, or yr, of the resultant force. First, we're going to solve for the weight of the wall. We're given that the gamma of concrete is 150 pounds per cubic foot, so we can just solve the weight of the wall as the gamma of concrete times the volume. So plugging in all of our values and using L for the length of the wall into the board, we get the total weight as 400 L pounds. Next, we're going to solve for equilibrium. We're going to use the moment of 0 from our free body diagram as equaling 0. This will give us an equilibrium equation to solve for the resultant force. And we get the resultant force is equal to 133.3 L over L. Since we want to solve for h, we're going to solve for little l in terms of h. We can think of little l as equal to h minus the resultant force height, which when we expand that gives us the following equations. And solving all the way through, we get little l is equal to little h over 3. Plugging that back into our resultant force, it simplifies down to 400 big L over little h. We need to solve for the pressure. We can use the equation Fr is equal to the pressure at the centroid times the area of the wall. This equates to the gamma of water times h over 2, which is halfway up at the centroid, times the area of h times big L, which again is the depth into the board. This simplifies down to 31.2 big L h squared. And then we can equate this equation to our original resultant force solution, and to solve for little h, which gives us h cubed is equal to 400 over 31.2, which solves for h as equaling 2.34 feet.